Now that we've practiced graphing one line at a time, we're going to graph more than one line at a time to solve a linear system. A linear system has more than one linear equation in it, and a solution to a system of equations must satisfy every equation that's in the system. There are three types of solutions that we can get when we're solving a system. The first is a single point. When we graph our equations, if the lines intersect in a single point, then that point of intersection is the solution. The next type of solution is infinitely many points. That type of solution happens when our equations actually describe the same line. They may look different, but when we graph them, they are the same line. And the third type of solution is no solution. That's because we have parallel lines. Their slopes are the same, and so they never intersect. Let's look at example 1, where there will be one solution to our system. Notice our system is made up of two lines, y equals 2x minus 3 and y equals negative 1/2 x plus 2. The solution must be true in both of those lines. So first let's graph them. Y equals 2x minus 3 has a y-intercept at negative 3 and a slope of 2. So up 2 and over 1, and draw the line. Since we're going to read the intersection off the graph, you're going to have to plot these very carefully. Look at our second equation, y equals negative 1/2 plus 2. There's a y-intercept at 2, and if we count our slope of negative 1/2 from that point, we can go down 1 and over 2. And we could continue down 1 and over 2 and draw our line. Those lines intersect at the point where x is 2 and y is 1, so that ordered pair of the intersection is our solution. If we substitute 2 for x and 1 for y in the first equation, it will give us a true statement. If we substitute it into the second equation, it will also give us a true statement, and that's the only point that makes both of the equations true. Look at example 2 and write down the rest of the problems. 2x plus y is equal to 1, x plus 2y is equal to negative 4. If we're going to solve these by graphing, then maybe we should solve them for y and plot the y-intercept and the slope. But you could also plot these using x and y intercepts if that's easier. So it's really up to you how you graph them as long as you're careful in your graphing. To solve the first equation for y, I subtracted 2x from both sides. So y is equal to negative 2x plus 1. The y-intercept is at positive 1, and the slope is negative 2. So I'm going to go down 2 and write 1 from the y-intercept. The first step to solve the second equation for y is to subtract x from both sides. So I get 2 times y is equal to negative x minus 4. I still have to divide everything by 2 to get y by itself. So remember that every term gets divided by 2. When I simplify the fractions, y is by itself, and then I have equals negative 1/2 x minus 2, so a y-intercept at negative 2, and a slope that's negative, so down 1, and to the right 2. You can see that the lines intersect on the grid when x is 2 and y is negative 3. So that's the solution to our system. In example 3, they tell us ahead of time that there's going to be no solution. So let's see what that looks like. This time I'm going to graph by using the x and y intercepts, but if you want to solve this for y, then you can do that. So I'm going to take the line x minus y is equal to 2, and to find the y-intercept, I'm going to let x be 0. If x is 0, then negative y is equal to 2, which means that positive y is equal to negative 2. Now I'm going to find the x-intercept by letting y be 0. If y is 0, then x minus 0 is equal to 2, means that x is 2. So I can plot those intercepts. X is 0, y is negative 2. and then x is 2, y is 0, and draw my line through those 2 points. I'll do the same thing for the other equation, x minus y equals -1. If x is 0, then negative y equals -1, which means a positive y is equal to positive 1. If y is 0, then x is equal to -1. Now I plot those points. When x is 0, y is 1. And when x is -1, y is 0. And then I draw the line. These lines are parallel because they have the same slope. They never intersect, so there's no solution. In example 4, I decided to solve each equation for y. When I take the first equation and subtract 3x from both sides, I get -9y equals -3x plus 18. To get y by itself, I divide every term by -9 and simplify. -3 divided by -9 is a positive 1/3 times x, and 18 divided by -9 is -2. So that means that I have a y-intercept at -2 and a slope of positive 1/3, so up 1 and over 3. When I solve the second equation for y, first I subtract x from both sides, then I divide every term by -3. And notice when I simplify that, I have y by itself. -1 divided by -3 is positive 1/3 times x, and then 6 divided by -3 is -2. And if you compare that to the first line that I simplified, they look exactly the same. So if I graph this, it's going to have a y-intercept at 2 and a slope of 1/3, and ends up being the same line. They share all the points on the line. So that means we have infinitely many solutions. In all of these examples, we were able to graph our lines, and the intersections, if there were any, were on the grid. So we knew exactly what the numbers were for our x and our y values. But if our intersection happens not where the grid crosses, then that means our answers are decimals or fractions, and that's a lot harder to estimate accurately. So we need a calculator to help us out. I'm going to show you how to graph and find the intersection on the TI-84. You can use any graphing calculator that you want. I'm also going to show you how to do it on Desmos. But if you use a different calculator, then you're going to have to look up the steps for solving by graphing on your own. Using the TI-84, we have to solve each of our equations for y. So pause the video and go ahead and solve each of these equations in the system for y. So one shortcut that you can take if you're going to type it in the calculator is not simplifying your fractions. The calculator is going to graph it for us. So instead of dividing each term individually by the 7 to get y by itself, I'm just going to make one big fraction right there, and I'm going to let the calculator handle the y-intercept and the slope on its own. So now let's go to the calculator. I've included the steps that you need down below, but make sure that you follow along with my keystrokes. My keystrokes will appear in red. Now your calculator screen may look different than mine. If that bothers you, then just press clear. So you can see my keystroke there, and now that screen is clear. We want to graph, and that happens in y equals. So notice the key that turned red there, and I have something in there because I've used this calculator for something else. So I want to press clear, and that will give me empty slots on y1, y2, y3, all the way down. Notice your plots across the top. I can up arrow and I can access those plots. All of those plots should be off. Right now they're off because they're not highlighted. If I press enter and then go over, you see that that plot 1 is highlighted. If that's highlighted, then that means that your graph is not going to plot correctly. So make sure that none of those are highlighted. Now we can type in y1 our first equation. The y1 stands for our y, so we're just going to type what comes after the equal sign. So -2x minus 7. Notice I'm using the negative in front of the 2x because that's multiplication, and the minus in front of the 7 because that's subtraction. Now I can press enter and go to the next equation, y2. I want to type this in as a fraction just so I have the grouping right. So I did alpha x, and then I can type negative 5x plus 7 in the numerator, arrow down, and put 7 in the denominator. Now we want to set a good window for finding our intersection, and a lot of times you can do that in a standard window, especially as we start out here. So rather than pay much attention to the window, I just want you to press zoom, which is right in the middle, and then 6 is zoom standard. So just type that number. If I can see the intersection of the two lines in my window, in my screen, then that means that that window will work. So here are the keystrokes to find that intersection. We're going to second trace, which means calculate. We get a calculate menu, and we want to calculate the intersection, so I'm going to type the number 5. Now it goes back to my graph, but on the bottom it's asking me for the first curve, and it has Y1 in blue highlighted. That's what I want, so I'm going to press enter. And then it shifts to my second Y2, which is in red, and it's asking for the second curve. That's my second curve, so I'm going to press enter on that. And then it asked me for a guess. The guess is really in case you have more than one intersection. We only have one intersection, so we're going to press enter through the guess. So it's a lot of keystrokes, but most of that is just pressing enter to accept what the calculator is giving you. Notice when I press enter after the guess, now it's giving me the intersection at negative 6.222 and y equals 49/9. It's giving me the fraction for the y because I entered a fraction in my y equals. It's probably a good idea not to mix decimals and fractions, so I'm going to go back to my y equals, and I'm going to put a decimal somewhere in this fraction, like after a number. I'm going to put it in the denominator, but you can put it after any number. When I do that, that's the only change I made, and I go back to graph, and I find that intersection. We'll go through those steps again. Second, trace, intersect, first curve, enter, second curve, enter, guess, enter. And now you see that I'm getting an XY ordered pair that's just in decimals. We're going to round those numbers. Let's give 2 decimal places. When we write our answer as an ordered pair, we're going to have negative 6.22 for the X and 5.44 for the Y. Let's see what it would look like to solve that same system in Desmos. So in your browser, go to desmos.com, and when you do, you will see this code. We want the graphing calculator. And for Desmos, we do not have to solve for y. We can type it in exactly the way it's given. When I type each equation on its own line, just the way it was given to me, then it graphs the lines for me. And you can see the intersection point has a little gray dot on it. If you touch that dot, then it will show you what that intersection is. So it's really easy to graph lines and find the intersection in Desmos. If I pinch the screen together using the mouse or my fingers, then I can change the window, I can zoom out, and I can zoom in. Make sure you practice using the TI-84 and the keystrokes that I gave you, and also practice using Desmos as you work through your practice.